Hello student, in this video we will discuss about the viscosity. So what is viscosity? It is the property of the liquids. Viscosity is the property of the liquids. By virtue of it opposes the force, an opposing force comes into play in between the different layers of the liquid. As we know, liquid has different layers. Suppose if we take a beaker and this beaker is filled with water and filled with water, and the water, if we stir this water, then the liquid will be there in the form of these layers. Liquid starts moving with the form in the form of layers, and these layers and different layers opposes the force. These are the relative motion. We can say this is a relative motion, and one layer opposes the motion of the other layer. There will be different layer of the water, different layer of the liquid. So the property of the opposing force, there is opposing force between the different layer of the water. So this property of the water, by virtue of it, an opposing force comes into play between the different layers of the liquid whenever there is a relative motion between the layers of the liquid, is called viscosity. So we can say viscosity is the property of the liquids. This is the property of the liquid due to which an opposing force comes into play between the different layers of the water. Different layers of the water, there is different layers. One layer opposes the motion of this layer, and this layer opposes the motion of this layer, and different layers are there. So each layer opposes the motion of the other layer. Means there is a relative motion between the two layers. So an opposing force which comes into play between the layers of the liquid are called as viscosity. So now coefficient of viscosity. What is coefficient of viscosity? Coefficient of viscosity. How can we find coefficient of viscosity? So coefficient of viscosity is, here we will also consider different layers of the water. So you have seen, if you have crossed any river, so you can see that if we move from a point, and when we cross the river, so we will be there. We have start moving from this point, and after crossing the river we will be there. Means these liquid has different layer, and different layer has different velocity. This is the surface, and the different layers, these different layers has different velocity, and each layer opposes the motion of the other layer. So here we consider that the velocity of if v is the velocity of this layer, or we can consider two layer, any two layer we can consider here. So suppose uppermost, we will take two uppermost layers. Suppose this is layer A, and this layer is A, B, and this is C, D. So if V is the velocity, suppose V is the velocity of this layer. We are comparing two layers only here. What different layers? There are different layer of the water, and these layer opposes the motion of the other layer. Means this layer will opposes the motion of this layer opposes the motion of this, each layer. Here we have considered only two layers. The velocity of the layer AB is V, and the velocity of this layer is V plus increased velocity. This velocity, the velocity of this layer will decrease. So we have considered the velocity of A, B is V, and C, D is V plus D, V. Why it is its velocity is less? Because this layer opposes the motion of this layer AB. Means an opposing force will act here, an opposing force. That force decrease the velocity of this layer AB. Means CD decrease the velocity of AB. Means an opposing force comes into play between these two layers, and this force, opposing force, is called as viscosity. An opposing force, this is the property of the liquids, property of the liquid by virtue of which an opposing force comes into play between these two layers. Now we have to calculate coefficient of viscosity here. So what is coefficient of viscosity here? We have we know that an opposing force comes into play between the two layers. Now on what factors this force depends? This force depends upon, first one is, this force depends on this force is also called as viscous drag force, and this force is, number one, directly proportional to the area of the layer. Area, number one, this F is directly proportional to the area of the layer, and second point is directly proportional to the velocity gradient. F is directly proportional to velocity gradient. So how can we write velocity gradient? d dx of v. This term can be, we can read this term velocity gradient. This is called velocity. V is velocity. This is called velocity gradient. So combining these two equations, we get F is directly proportional to A into dV upon dx. Now F is equal to proportionality. We have to write it proportionality to equality. So for that we will put here some constant, and that is eta into dv upon dx. So this eta is called as coefficient of viscosity. This eta is called as coefficient of viscosity. And negative sign, what this negative sign shows? This negative sign shows that there is which is the force, this is called viscous drag force. The direction of the viscous drag force is opposite to the direction of the motion of the liquid. So from here eta can be written as, eta is equal to, or first of all, one thing more we can put here, if this area is equal to, if we consider here area is equal to 1, and the velocity gradient, that is dv upon dx, is equal to 1. Therefore we can write from this equation that F is equal to eta. F is equal to eta. This negative sign to show the motion of the opposing force. There is a opposing force, means the direction of the viscous drag force is opposite to the motion of the layers. So this eta is called as, so from here we can write that this eta, coefficient of viscosity, this eta is called as coefficient of viscosity. So coefficient of viscosity of a liquid is defined as the viscous drag force acting per unit, viscous drag force acting per unit area of the layer having unit velocity gradient. Unit means 1, means unit velocity gradient. Now from here we can calculate the unit of, if we have to write the unit of this coefficient of viscosity, that is unit of eta. Coefficient of viscosity eta, coefficient of viscosity is eta. So from this equation we can write what is the value of eta. So eta is equal to F upon, from this equation eta is equal to F upon, this is here we will write A also, F upon A into dV upon dx. So we can write the unit of force is, unit of force in, if we write in CJ system, the unit of force is dyne, and area, unit of area is centimeter square, and dv upon dx means dv means centimeter, means velocity, centimeter per second, upon dx means distance, that is distance between two layers, that is centimeter. So here centimeter with 1 centimeter cancel, we get dyne this dyne per centimeter, or yes, 1 centimeter is there, so per centimeter square, here centimeter 1, here 1 centimeter square, and into second, dyne second per centimeter square, and this is called as, or poise, this is called poise. This dyne centimeter square per second is called as dyne. Therefore 1 poise is equal to, we can write 1 poise is equal to 1 dyne second per centimeter square. And in the same way, in SI system, if we write the unit in this SI system, then we get in SI system F is equal to what is the unit of coefficient of viscosity here, that is equal to Newton, here dyne at the place of dyne, Newton meter per meter and into second, and Newton per meter into second is called as decapoise. This is called as decapoise, and 1 decapoise is equal to, we can write decapoise, 1 decapoise is equal to 1 Newton per meter second. And we can derive the relation between decapoise and poise. So relation between decapoise and poise, So what is the relation? We know what decapoise is equal to. 1 decapoise is equal to 1 Newton second per meter square. So here we can write 1 Newton is equal to how many dyne? 5, 10 raised to power 5. 1 meter is 1 second. 1 second is equal to 1 second, and 1 meter 100 centimeter, that is 100 square, minus 2, power is minus 2. So we can write here, this is equal to 10, this is equal to, this is 10 raised to power 5 dyne into 1 second into 10 raised to power minus 4. So we get 10 here, 10, this is equal to 10 dyne second, and here it is centimeter square, it is centimeter square per centimeter square. So 10 dyne per centimeter into second, and this is equal to poise, means 1 decapoise is equal to 1 decapoise is equal to 10 poise. So this is about the viscosity, coefficient of viscosity, and relation between poise and decapoise.